All right, hi guys. We are looking at the last part of our transformations for the year. Woo, we made it. Last part here. All right, so we're still looking at transformations. We're going to finish off strong. Our last transformations that we're going to be working with all together is for the square root transformation. We looked at quadratic, we looked at all of the inside parts, the outside parts, and that multiplier number. So now we're going to do the same thing with the square root. All right, so there at the top of our notes, there is the square root parent function, the positive or negative a value times the square root of x minus h plus k. So we're going to start off with the horizontal shift, which just means how far left and right. This is the left and right move. And the big thing here, remember guys, is insiders lie. So inside that square root, those parentheses do not have to be there. But is the information inside that big square root sign or is it outside of it? That's what you need to ask yourself first off. Is it inside the square root or outside? So this time, our square root function is inside, we have x minus h. Insiders lie, so again, we will shift to the right. Okay, insiders lie, so we shift to the right. When it becomes a plus, x plus h inside the square root, that's when you move to the left, inside those square roots for the plus. So let's just review that a little bit with our pictures. All right, so here's our first picture. Every graph has those initial starting points, some kind of key points here. And here's our starting graph that I highlighted here in orange, and it's labeled original. All right, so again, we have moved from left to right. So this is showing you an x minus h inside the square root. This is showing you the x minus h inside the square root. We move right. We move to the right. And again, when that same starting graph has been shifted, there's our same starting graph, labeled original. When that same starting graph is now moved to the left, this is our x plus h inside those square roots. Okay, so again, insiders lie here. We've shifted either left or right, but again, notice those points really didn't move. Each one just shifted over. Same thing is true for the other one. Those starting points, all they really did was shift over. So let's bring in our second transformation that we looked at, which is our up and down move. All right, this time we're looking at outside of those parentheses. Let's start with the up, our plus k here. Plus k, again, outside of the square root, means you are going up, because remember, outsiders are honest. And if I have a minus number outside of those square roots, this was your down, because again, outside's honest. So again, for our pictures, there's my original with those same starting dots. And it was shifted up. Every one of those starting dots just moved up. And this is our plus k. All we did was move up. Now, when that becomes the minus, again, there's my same starting dots and my same starting graph labeled there. Then I have my minus k, because all we did was take these starting dots and shift down. Took that same shape, shifted it down. So up, down, left, and right, guys, do not change the shape of the graph. They just move it around. They just translate it. Now, what does affect the shape is that A number on the outside, and that's what we're looking at next. There were a couple of things to keep in mind that were a little bit different about the square root versus the quadratic. And that first thing is the A positive or negative? All right, together, a positive one and a negative one form the whole entire sideways U. But right now, our positive A, if A is positive, that just gives you the top side. When it becomes negative, that's when you get the bottom side, and you have what's called a reflection. There is no reflection when A is positive because it's just staying on the top. So if I look at these two starting graphs, again, this one, my original, that's above the x-axis is my positive. This one that is below the x-axis is my negative. And together, there's my positive side, there's my negative side. When we put the two together, that's when you get the whole entire graph. Now, let's see what happens when we actually look at just the numbers. We don't care anymore right now if the number's positive or negative, just what is the number. So ignore the negative sign. This is when we talked about absolute value of that A. So when the A by itself is bigger than 1, maybe a 2, maybe a 3, maybe a 4, that was the vertical stretch. So notice you've got those same starting points. Only now with a vertical stretch, check it out, they still start at the same place, that 0, 0. But from your original to the new, they grow in the amount of space. It's being stretched upwards if it's positive. When it becomes negative, and that number is still bigger than 1, they still start at the same place, but it's still pulled farther away from the graph. It's just on the bottom side. So the graph gets taller, the graph is getting longer on us. Okay, it's going up more and it's going down more. That sideways U is opening up. It's getting wider. Now, when that A value, again, the absolute value of A, not really focusing on the negative number, just what is the positive version of that number, is between 0 and 1. Maybe 0.25, 1/2, 0.8, 9/10. That's when you have what's called the vertical compression. And that's when we start squishing the two sides of that graph closer together. So let's look at the bottom here for a second. So again, there's your original, your same starting points. Notice they still start at the same when we do that vertical compression, but now it's being squished. Every point on the original is being squished flatter down to the x-axis. It's getting flatter here. Same is true for the bottom side, the negative. You have those same starting points, your same starting graph, but when that number is between 0 and 1 and negative, again, it's just getting flatter. It's being squished towards the x-axis. And that is your A value when it's between 0 and 1. Remember, that means you're getting squished. You're being flat. That is a vertical compression. It's being squished in. All right, guys, so I hope you enjoyed learning a little bit about your transformations with your square root functions. Hang tight for the second part of this video when we talk about all the different vocabulary together and how we pull it all out of an equation. So hang tight for part 2.